very warm welcome, especially to our guests from outside, Vice Chair of the Planning Commission, also ICIMOD Board Chair, that's Dr. Ravindra Sakya, Ambassador Asko Lukainen, special guest, Dr. Grunsfeld, also Karen Feldstein and Hannah Singer. ICIMOD, we're very lucky to have a program like Servir, which means to serve mountain people in this case, to work together with USAID and NASA to make that happen. But it's not just that, it's a whole partnership. And I'm happy to say that we have so many of our partners in the room today from various universities and academic institutes from Nepal. Thank you all very much for coming. Can we put our best minds, our best technology, our best people, really our best science minds anyway, to solve some of the biggest pressing problems that we have on Earth today in our Hindu Kush Himalayan region. How to do that. So we know we have a region that is an area of extreme poverty. We know there's a lot of ecosystem degradation. On top of that, climate change is a big issue. We hear about melting glaciers, of course, quite a bit. But how can we really contribute to the well-being of mountain people?
Just a little over 3 years, on October 5th, 2010, we had Charles Bolden, NASA administrator, here with us, with Jose Asas, Deputy Administrator of USAID, then Environment Minister from India, Jairam Ramesh, and many other regional stakeholders. We kicked off a program, Servir. And the main crux of this program is how we can take the top-notch science and technology in the context of the development. And more so from the ICIMOD perspective, it is in the context of mountain development, in the context of sustainable mountain development. Now when we say about this region is possibly because of its inherent characteristics of the topography and the difficult terrain and access. This is one of the least monitored region or a space on Earth. And I think there is no better way than to see from the space, to get a bird's eye view, to have this monitoring of this Earth system, or the mountain system as such. And there is also a lot of momentum movement at the global level, more so over the last 1 decade or so, since WSST in 2002 in Johannesburg, the importance of Earth observation, to understand our environmental parameters, and bringing this information to the societal benefits. And in that context, that we are very happy to partner and offer our gratitude from ICIMOD to NASA and USAID to bring this survey program and connecting from space to village.
I really appreciate the warm welcome. Namaste. I grew up in a small town in Illinois called Chicago of about 5 million people, about the same size as Kathmandu, very far from the mountains. Yet growing up as a boy, I had a couple of interests, one of which was to become an astronaut, which was only a dream, and the other was to go to the mountains. And as I was growing up, I started going to the mountains in high school in the United States and then around the world. And I also continued to study science. And I think as scientists, and many of the things that have been said about the mountain environments, about biodiversity, but as scientists we love to study the details of things, but not always the societal or the social impacts of the science. But our world is evolving more rapidly now due to changes created by humans, a loss of biodiversity, a warming planet, that I think ICIMOD is really at a unique place and a unique opportunity where scientists are waking up that we can't just talk about the science we do, we have to become involved with the communities that are most affected. Being an astronaut, when I say the communities that are most affected, I mean the people of planet Earth. I flew 5 space missions, and on each of those space missions, I had many different goals. To do science, my first mission was astronomy, to repair the Hubble Space Telescope, but I had another goal when I went to space, and that was to look down on the mountains of the Hindu Kush, the Himalayas, and imagine what it would be like to be there. And so this is my first trip here. Looking at planet Earth from hundreds of kilometers up, the Earth looks very smooth. It's very hard to tell any type of topography or elevation at all, except in this region. When you fly over, and our eyes are only 6 centimeters apart, but you really get the feel that there's, a plateau that's at about 1,000 meters, and then a transition to over 8,000, and then back to this very high plateau in Tibet. It's one of the few places on Earth that you really have a feel for the great forces that are at work in the Earth, but also the enormous diversity between the plains of India, Nepal, and then up into the mountains in Tibet. As I've traveled the world, indigenous mountain communities tend to have very happy people, and we want to preserve that as well. And the stressors that the rest of the world is putting on our mountain communities makes it very difficult because of many different things. And as modern culture comes to some of the more remote mountain towns, it doesn't always have a positive result. So that's something that I'm very glad that you have folks here who are in the social scientists. And we're trying to answer some very fundamental questions, human questions, that are truly universal. Some of them, how did the universe form? What was the beginning? This is common to all cultures. Where did we come from? How did the building blocks of our bodies form to be able to create ourselves, mountains, water, the chemical elements themselves? And we look to astronomy to answer that, and we can answer that using our science tools. What causes weather, earthquakes, or climate change? Something that you're making great contributions here to, and that we're making from space to help apply from space to village. Climate change in particular is a global problem, and the science of trying to understand that, may be the first step in a key in a chain to help explain to policymakers and decision makers, what we can do. Now the climate always changes. The climate's been changing for millions of years, for billions of years on Earth, but never more rapidly in the ways that we can trace by scientific means to human activity. So at NASA we have science. In science we have various divisions. We have our Heliophysics division that studies the physics of the sun and the connection of the sun to the Earth. So we have our Earth Science division. Our severe program is part of that Earth Science division. The Earth, of course, is one of our planets, so we have a Planetary Science division to study the other planets. And then, of course, our sun is a star. Our planets leads us to astrophysics. I like to say science is the international language of peace. I hope science becomes the international language of understanding our planet, our environment, and how we can sustain life on Earth and have biodiversity. And the Earth is very complicated. I said, all terrestrial weather is the sun and the rotation of the Earth, but the details turn out to be really important. And you have to put in details such as ocean salinity and temperature. This is the Gulf of Mexico showing a warmer temperature than out in the Atlantic. You have to put topography in because that drives the motion of moisture upwards. And all the forces and rotation of the Earth, of course. And it's very complicated, but this is not real weather. This is a model, and it includes ocean currents and other things. Yet, even though it looks convincing, when you get down to the regional county scale or the cloud size scales, it doesn't work very well. We still don't have enough detail. And so we use a variety of spaceborne measurements, ground-based observations, and models to try and understand, for instance, glacier changes in Asia. As we measure, this is something we just heard about, as we measure global glacier mass, we can see that overall glaciers on the Earth are disappearing. So the large circles, for instance, where we are here, shows the area of the glaciers, and then the red shows the mass change in gigatons per year. And I'll point out that the red means negative. And outside of the polar caps and Greenland, you have the largest reservoir of fresh water locked up in ice and glaciers here in this region. But everywhere we look, in the Alaska Range, in the ice cap in South America, we see enormous amounts of loss of glaciers in this short period. And more recently, it's accelerated even more. But I like to point out that Earth science, from a science point of view, is not only very interesting and challenging, it's also very important. It's very important to the people who live in regions that are most affected. And you've seen pictures like this before. This is May 20th, 2013. This is from our MODIS, from our Aqua satellite, and just a very short time later you can see the large flooding in the Ganges River Delta. So, and of course you also heard about mapping fires, so I don't have to say very much about that, again from the Aqua satellite, but now we can also use the SUMI day-night bands, which can see very accurately where the base of these fires are, and when you zoom in, all of these red areas are forest fires, many of which are caused naturally, but some of which are also caused by humans. So you've heard this already, but we're trying to use the enormous wealth of earth science data that we get through our applications program to connect science with the end user needs. Our mission at NASA is to innovate, explore, discover, and inspire. The people we need to inspire are, of course, our young folks. Equal importance is also to help to inspire our decision makers. And maybe the most important decision makers of all, which are parents, and try and get them engaged with the science and excited about the science and the social networking tools. So with that, Dhanyabad, thank you very much.